So let's solve this question. This has been asked in GATE 2014. We have been given two numbers and we have been asked to find how many x comma y value pairs are possible. That means for certain pairs of values of x and y, I'm sorry for that. For certain pairs of values of x and y, this equation will be satisfied. And we have to find out how many such pairs are possible. Okay. Again, if you have to solve such questions relating to bases of number systems, the best way is to take each number given at each side of the equation and convert it to a decimal number. In that way, we will be able to calculate or manipulate the numbers further because they will be in the same base. So let's proceed. How do you convert a number into decimal number system? By taking the sum of the positional weights. So let's solve this question. We have, okay, I'll just change the color of the ink. I've used blue ink for the question. I'll go for black for the solution. Now see, I've been given 123, right? 123 base 5 equal to x8 base y. Now I'll convert each of these numbers into decimal. So I'll take this because that will help me to examine the values of x and y further. It's not possible to, because we are not familiar with other number systems that much. We mainly work with decimal number systems in our daily lives. So it's better to take a number given in any other number system other than my decimal number system and convert it to base 10. In that way, we can simplify the task of finding the answer. So let's do this. Now here I have to take the sum of the positional weights. See, 3 is my LSB. So I start with it. 3 into 5 raised to the power of 0. Why? Because 5 is my base and this has the least positional weight. Its positional weight is 0. The positional weight of 2 is 1 and the positional weight of 1 in this case is 2. Right? Because the decimal number system is a positional number system where each symbol will take on different values depending on its position in the number. So 3 into 5 to the power of 0. So it will increase. I'll get 2 into 5 to the power of 1 plus 1 into 5 raised to the power of 1. And this is same as 8 into y raised to the power of 0 plus x into y raised to the power of 1. Just a word of advice, whenever you convert from any number system to decimal, always write the values from right to left, because when you are proceeding from right to left, there is an increase in the positional weight. See, you have to the power of 0, you have to the power of 1, you have to the power of 2. So the positional weights are increasing from right to left. So it's better to write the numbers from right to left and not the other way around. If you write it from left to right, it's not a mistake or there won't be any problems, but it may so happen that you get confused at times and you end up making some calculation errors. So it's better to go from right to left because that is the order in which our positional weights are increasing. So now if I do the calculation, I'll get 5, here I'll get, no wait, I think I've made a calculation mistake myself. So I have 1 into 5 raised to the power of 2. Right? This is 5 raised to the power of 2 because 1 has a positional weight of 2 in this case. So here I'll get 25. I'm sorry about that. So you have 2 into 5, you get 10, and here you get 3, which is same as xy plus 8 because anything raised to the power of 0 is 1. So here you get 25 plus 10, 35, and 35 plus 3 is 38. Now if you subtract 8 from 38, you are left with 30. So my final equation is xy equal to 30, right? Now, how do we proceed from this point onwards? Coming or reaching this step was not that difficult. From here onwards, to find the value pairs won't be that difficult either if you closely examine these two numbers x and y for a moment. See, what are the constraints on x and y? Now, before talking about the constraints, let's just list out the values, the possible values that we have for x and y, the product of which will give me 30. Okay, let's just list them out. Okay, so let's go one by one. Here we have first x and then we have y. So if x takes on a value of 1, then y should take on a value of 30 in order to satisfy this equation. Similarly, if x takes on a value of 2, y will take on a value of 15 to satisfy the equation. If x takes on 3, y should take on 10. If x takes on 5, y should take on 6. If x takes on 6, now it will simply change. If x takes on 6, y should take on 5. And so I'm running short of space. I'll just divide it into 2 halves. And now if x takes a value of 10, y should take a value of 3. And if x finally takes a value of 15, y should take on 2. And if x takes on a value of 30, y should take on a value of 1. I hope I've listed out all the possible combinations. Yeah, I think I have 130, 215, 310, 5, 6, 6, 5, 10, 3. Yeah, I'm going in the reverse order now. See, 5, 6, the values have interchanged. 10, 3, 310 has become 10, 3, 215 has become 15, 2, 130 has become 31. So I'm back to the starting point. That means I've covered all the combinations. Now see, can I take in all these combinations into account? I cannot. Why? Because there are certain restrictions on x and y. Right? What are some of these restrictions? See, let's just examine each pair one at a time. I have x equal to 1, y equal to 30. Now see, if I place x equal to 1 and y equal to 30, will there be any violation of the rules of radix? No. Why? Because if I place x as 1, then, and I have along with it 8, and x has a value, and y has a value, sorry. So I'm talking about this. I have x as 1 and I have 18 here, and the base is 30. If the base is 30, this signifies that it can take any values in the range of 0 to 29. This is the range it can cover. And x is taking on a value of 1. See, if the base is 30, the possible symbols rather are 0 to 29. So 1 and 8, these are two valid symbols. That means 1, x equal to 1 and y equal to 30 is a valid combination. Okay. Now what about this x equal to 2 and y equal to 15? If I place x equal to 2 and y equal to 15, once again, it's within this range, right? X is a value of 2, which is an allowed symbol because the base is 15. Now, if the base is 15, then the possible values that will be allowed in this number system, in the base 15 number system, will be 0 to 14. And x has taken on a value of 2. So, this is perfectly allowed. And this combination is valid. What about this x equal to 3 and y equal to 10? See, if x equal to 3, y equal to 10, once again, there won't be any problem. So, if x equal to 3 and y equal to 10, once again, the possible values will be 0 to 9. So, this is also very much allowed. And this is a valid combination. What about this? X equal to 5. X equal to 5. Now, this is interesting. Look at this. If x equal to 5 and y equal to 6. See, if the base is 6, then the possible values that this number can take on, or the possible symbols that are allowed in this number system, will range from 0 to 5. But I have an 8. So, this cannot be allowed. So, this is not a valid combination. What about this? X is equal to 6 and y is equal to 5. Once again, not allowed. Why? Because there is an 8 here. And if the base is 5, the possible symbols will be 0 to 4. So, this is once again an invalid combination. What about this? X is equal to 10, y is equal to 3. Not allowed. Because the possible values would be 0 to 2. So, this is rejected. If x is 15, y is 2. Not allowed once again. And if x is 30, okay, if x is 30, can y be 1? Definitely not. Definitely not. So, even this is discarded. So, how many xy value pairs are we getting? 1, 2, 3. So, the final answer is 3 value pairs. We are getting 3 valid value pairs. Okay? I hope this helps. Thank you.